This is the video for Accelerated Geometry on Section 1-2, Day 3. In this video, we will divide complex numbers. To begin, do you remember that expressions in simplest form cannot have square roots in the denominator? Does I count as a square root? And the answer to this is yes, because I is really equal to the square root of -1. So if we can't have square roots as a denominator, you also cannot have I as the denominator. So let's look at what we do when we have I in the denominator. Our first problem says 3 plus 10i divided by 5i. What we need to do is multiply the numerator and the denominator by the complex conjugate. So in this case, your denominator is 5i. The complex conjugate of 5i is -5i. So we're going to multiply the top and the bottom by -5i. So up top, we're going to distribute this. So that's going to give me 3 times -5i is -15i. 10i times -5i would give me -50i squared all over. Multiply the bottom. So 5 times -5 is -25. And I times I is I squared. Now, make note to remind yourself that I squared is equal to -1. So anytime I see I squared, I'm going to replace it with -1. So this is really -15i minus 50 times -1 over -25 times -1. So this is going to be -15i. -50 times -1 is a positive 50. And -25 times -1 is positive 25. Next thing you want to do is put this in standard form. So the numerator needs to be rewritten in standard form. So the real number is going to come first. In this case is 50. And then the imaginary number of -15i. And that's all over 25. And then we're going to break this up into two fractions. So the first fraction comes from the real part. So that's going to be 50 over 25. The sign in the middle is the sign in front of your second number. So in this case, it's going to be a minus. And then your second fraction comes with your imaginary number of 15 over 25i. And then lastly, make sure that your answers are simplified. So 50 over 25 reduces to 2. And 15 over 25 reduces to 3/5. So our final answer for this problem would be 2 minus 3/5 I. Let's try another one. Now we have 2 plus 8i over 4 minus 2i. So we need to multiply the numerator and the denominator by the complex conjugate of the denominator. So we're going to multiply by 4 plus 2i over 4 plus 2i. So up top, we're going to have to FOIL because we have two binomials here. So 2 times 4 is 8. 2 times 2i would be 4i. 8i times 4 would be 32i. And 8i times 2i would be 16i squared. On the bottom, we're going to multiply again using FOIL. So 4 times 4, 16. Then you have plus 8i. -2i times 4 is going to be -8i. -2i times positive 2i is going to be -4i squared. Let's do some simplifying. So we have 8. Go ahead and collect like terms here. So 4i and 32i is going to give me 36i. This is really 16 times -1. On the bottom, you have 16, positive 8i, negative 8i. They're going to cancel. And then you have a negative 4i squared. So that's going to be negative 4 times negative 1. So now we really have that this whole thing right here, 16 times negative 1 is negative 16. So 8 minus 16 would be negative 8. And then this piece really becomes a plus 4. So 6 plus 4 would be 20. So I'm going to break it up. So we have negative 8 over 20 plus 36 over 20i. And if we reduce this, this is going to give me negative 2/5 plus 9/5 I. And that's your final answer. Example 3. Looking at this problem, what's the complex conjugate of the denominator? So the complex conjugate of negative I would be positive I. So up top, if we just distribute, that's going to give me 3i plus 8i squared. On the bottom, that's just going to give me negative I squared. So this is really 3i plus 8 times negative 1 all over negative negative 1. So that's 3i minus 8 over 1. Put this back in standard form. So my answer to number 3, or example 3, would be negative 8 plus 3i. One more. What's the complex conjugate of 2 minus I? And that would be 2 plus I. So up top, that's going to give me 6. 3 times I is going to be 3i. Negative I times 2 is going to give me negative 2i. And negative I times positive I is going to be negative I squared. On the bottom, 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is going to be negative 2i. And negative I times I, it's going to be negative I squared. Collect like terms. So this is really 6. Positive 3 and negative 2 is really going to make a positive 1i. And then that's really a negative negative 1. All over, that's going to be 4. Those cancel. And that's going to be minus a negative 1. So in reality, what we have here is 6 plus I. A negative negative 1 is really a plus 1. And 4 minus negative 1 is really 4 plus 1. So 6 plus 1 is 7. You have your plus I. Over 4 plus 1 is 5. So last step is to break this apart. So it's going to be 7 over 5 plus, there's really a 1 in front of the I. And then you have your I. So 7/5 plus 1/5 I.